Hi guys, Mr. Janowski. This is Chapter 35, Homework 3, Problem 6. So this is a simplifying a circuit kind of thing. We're going to try to figure out a bunch of things about this, and I'm going to break this video into two parts. The first part we'll do A, B, and C, basically simplifying the circuit all the way down, finding the equivalent resistance, finding the current leaving the battery, and then finding the power used by the whole thing. And then that'll take a while, so I'll do the second part, D, E, and F of this as a separate problem. So first, let me go over to here where I've got a little bit more room to work with. And yeah, we're trying to simplify this, get the equivalent resistance of the whole thing is what we need to do first. So let's see what we can do. R1 and R2 right here, these guys are clearly in series. So I'm going to circle these guys and say that our equivalent of this is just going to be 250 ohms plus 150 ohms. So that's 400 ohms. And then what else? Can't do anything with R3 at this point, but R4 and R5 are also in series. All right, so our equivalent for that is going to be, oh, that's a lie, 200 ohms. So that's R4 plus 300 ohms. So that is R5. That together makes 500 ohms. All right, so where do we go from here? Don't be lazy. Redraw your circuit. So we're going to have, let's see, here's the battery. That's 24 volts. And then coming up here, there's a split, and then R1 and R2 together, these guys are now, that equivalent resistance is 400 ohms. R3 is down here. That's still 350 ohms. And then R4 and R5, we put those guys together. So that ended up being 500 ohms. All right, so what can we do with this guy? I'll keep switching back and forth, green and blue. See how that works. 400 and 350, these guys are in parallel with each other. So let's get the equivalent resistance of that. So that's going to be our equivalent of that. Remember how we add resistors in parallel. 1 over 400 ohms plus 1 over 350 ohms. Take this to the minus 1. So in the calculator, 1 divided by 400 plus 1 divided by 350 gives me some big number, well, some very small number. And then I take that to the minus 1 power. It says 560 over 3 and has a decimal. That ends up being 186.6 repeating. All right, so we've got that. And where do we go from here? Don't be lazy. Redraw your circuit. So I still have 24-volt battery right there. And then the 400 and the 350 right here, remember we just found the equivalent resistance to that. So that is now 186.6 bar repeating ohm. Shame on me for leaving off the units. There we go, all better. And this is in, all right. This is going like this. Down here we have 500 ohms. So looking at this, the 186.6 repeating ohms and the 500. Don't let your eyes fool you. This kind of looks like parallel, but notice these guys are connected end to end along a single path. These guys are actually in series. All right, so back to blue. Adding these guys together is easy. This is just regular addition. So our equivalent is 186.6 repeating ohms plus 500 ohms. All right, so that's going to give me 686.6 repeating ohms. All right, and then the last step, don't be lazy, redraw the circuit. I'm kind of running out of room here. So there's our 24-volt battery. And at this point, we just have one resistor that is 686.6 repeating ohms. So that, by the way, is one of the things we were looking for. We were looking for the equivalent resistance of the whole thing. So the equivalent resistance of the whole circuit, RIQ of everything, is 686.6 repeating ohms. Okay, so there's one of our answers. Now, what other things were we looking for? All right, let's go back to here. Part B, the current leaving the battery. All right, how do we figure out the current? Well, we know the voltage. We know the resistance of the whole thing. So this is just Ohm's law. So I always like to start, just write the law as it is. V equals IR. We know V, we know R. We're looking for I. So that's going to lead us to I is equal to V over R. Okay, so I is equal to 24 volts over, and our equivalent resistance for the whole thing, 686.6 bar ohms. All right, ask the calculator. 24 divided by 686 point, a bunch of sixes, and we end up with 0.3495. Then it goes on. And what units would this have? This is I. So this is a current. Current comes in units of amps. So I've got that one too. And then the last thing we're going to find in this video is what is the power used by the entire circuit. Okay. So how do we figure out power? Well, we know current, and we know voltage, and we know resistance. How can we figure out power doing this stuff? It's going to be Watt's law. PIV. P equals IV. Okay, so P is equal to I, leaving the battery. So that I right there, 0. No, I made a typo. It's not 0.3. It's 0.03. Let me fix this. 0.03495. 0.03495 amps. Okay. So what do we have here? 0.03495 amps. Okay. That is our current. And what's the voltage? The voltage is the voltage of the battery. 24 volts. So take your current, multiply by 24, and I have P is equal to 0.8388. And in all of these, I'm keeping more sig figs than I'm really entitled to. I just do this on this kind of problem because there's less rounding. But anyhow, what are the units of this? It's a power. Power comes in units of watts. So there we go. We found the whole thing. So that's parts A, B, and C. Find the equivalent resistance of the whole thing, find the current leaving the battery, and find the power being used by the whole circuit. I'm going to stop this video here and make a second video for actually figuring out the current and the voltage, the current through and the voltage across each of the resistors, and the power being used by each of the resistors. So I'm going to stop this here. Hopefully you found this helpful.